My name is Isai and I'll be talking about how to use the difference quotient and how it relates to derivatives. So, as some of you may remember from pre-cal, the difference quotient is given by the limit as h approaches 0 of f of x plus h minus f of x all over h. And in calculus, you're going to be learning how to use the power rule. The power rule is basically a much more efficient way to take the derivative of a function. Now, let's see if we can try to apply this formula onto an example that we have written here. So our example here is x squared plus x. So just for this first part right here in the formula, we have the function of x plus h. So this means that we need to substitute an x plus h directly into wherever we have an x value in our function. So that means that we would get an x plus h quantity squared plus x plus h given as x squared plus x minus the original function, which is x squared plus x all over h as the limit of h approaches 0. So from here, it's basically all simplification. So the limit as h approaches 0, well, we have to FOIL that, right? So x squared plus 2xh plus h squared plus x plus h minus the quantity of x squared plus x. Now to get like terms, we can simplify it a bit more by distributing that negative, right? So the limit of h approaches 0 of x squared plus 2xh plus h squared plus x plus h minus x squared minus x all over h. Now the majority of these problems, because it's using the difference quotient, we're going to have some values that cancel out. So an example would be these x's right here and the x squareds. So we're left with the limit as h approaches 0 of 2xh plus h squared plus h, right? That's what's left over, all over h. From here, we can find the GCF of the numerator, so we get the limit as h approaches 0 of h times the quantity of 2x plus h plus 1, all over h. Now, the two h's cancel out, and we're left with the limit as h approaches 0 of 2x plus h plus 1. From here, we can directly take the limit of this value. So by substituting, we'd have to substitute the 0 into the value, so we get the limit, no more limit, I apologize, so 2x plus 0 plus 1, which basically simplifies down to 2x plus 1. And that would be our derivative for this function. Now the power rule is a little more complicated to understand, but it's very simple if you actually pay attention. So for the same problem, f of x equals x squared plus x. Now, power rule states that we have to drop this exponent down over here to the front as a constant of the variable, so we get 2x, and we would subtract the power of the exponent by 1. So 2 minus 1 plus, so this is to the first power, right? So we drop that down, so 1x, 1 minus 1. So 2 minus 1, so 2x to the first power plus 1x to the 0 power. Now, anything to the 0 power is 1, right? So we simply get 2x plus 1. And if you'll notice, it's exactly the same thing as what we did with the difference quotient. And so yeah, that's basically all that there is to these two concepts and how they're related. Might be a little complicated to understand at first, but hopefully you can kind of get the main idea of using the power rule.